Okay, so we're going to start from the very basics. Even though I've skipped one step for differentiations, uh, where you can use the first principle to differentiate a function. But either ways, I'll still get back to it if need be. But for a start, I'm going to just to introduce a very simple method when it comes to differentiation, or rather the concept that you need to know. If you are given a function, let's say y is equal to a x to the power n, I'm going to define to restrict a not to be 0, because if it becomes a 0, I'll have y is equal to 0. Still, you can differentiate y is equal to 0, and the answer is trivial, it's just 0. Yeah. So if you have a function of this form and then you are taught to differentiate, uh, you look at the power. Definitely, if it is in this format, you get your power and then you multiply with the coefficient, like the way I've done it here. So n times a, you get na. Now, this power here, you reduce by 1. In other words, I'm saying you subtract 1, like I've done n minus 1. Then you are done with the differentiation. And you should take note that when you're differentiating a constant number, as long as the number is constant, it is 0. Now, let's look at this particular example that I've written here. Well, I said f of x is equal to x to the power 4 plus 3x squared plus 4x plus 9 to differentiate this. So my power here, it is 4. So I'll get 4 times the coefficient here, and the coefficient is 1. So 4 times 1, that is just 4. I'll say this power 4 minus 1, and then I have a 3, the one that I've written there. And then I'll come to this term here. 2 times 3, that is 6. 2 minus 1, that is 1. Here there is 1, okay, x to the power 1. 1 times 4, that is 4. Now, 1 minus 1 is 0. So meaning that this x is raised to the power of 0. And the number, when it is raised to the power of 0, that is just 1. So 1 times 4 is 4. Differentiating this constant number 9, it is just 0. I'll explain that why that is a reason. Look at it. This is 9. This 9 is independent of x. Since it is independent of x, but there's an x which is raised to the power 0. Like the same principle that I've used here. X to the power 0 is just 1. 1 times 1, 1 times 9, that is just 9. That's why I've just written a 9. But now, if you differentiate this one, you're going to get this power. Remember, we're getting the power multiplied by the coefficient. So 0 times 9, that is 0. And the 0 times this term x to the power negative 1, it will be just 0. So differentiating a constant is always a 0. On B, so we're done. This is the answer. On B, we use the same method. 4 times 3, that is 12. Or I should have written a t. It is in terms of t here. Okay. So 4 times 3, that is 12. And then 4 minus 1, which is a 3. Now, look at the way I've written this one. This one, it is not in the standard form like the way I wrote my general function. It's supposed to not to be written as t. Using the principles of indices, once I take it on top there, it's going to be a negative 2. So I'll now say negative 2 times the coefficient is just 1, which is negative 2. And then this negative 2 minus 1, I have negative 3. So definitely differentiating just this part here, I'll have negative 2 t to the power negative 3. Of which I can take this one down here so that if I reciprocate negative 2, and then I have t to the power 3. This is the one that I wrote here. Now differentiating 10t, the same thing that we did on 4x, so we'll have 10. Differentiating 7, this is a constant number, we'll have 0. So this is the answer. We'll come here, this is 4 minus t to the power 2. Now it is in the brackets, then to the power 4. What do we do here? We use the aspect of substitution. So I'm going to say let u to be equal to what is on the inside, which is 4 minus t to the power 2. This is the one that I've written there. And then I'll differentiate this with respect to t. So du over dt will be equal to 2, This is 4 just 0, so 2 times negative 1, this is negative 2, and then reducing by 1, I have just 1, then it will be just t in this case. So du is equal to negative 2t dt. Now, since I said this is u, meaning that my y will be equal to u to the power 4. So I'm going to differentiate this one again with respect to u. So dy over du will be equal to 4 down, and then you reduce by 1. This is just a 3. So 4u to the power 3. Now we'll substitute back substitution. What is our u? It is 4 minus t to the power 2, which is the one that I just wrote there. And then what is our dt? Du. Du is negative 2t dt. This is the one that I've written there. And then I'll just multiply this one times this term over here, of which it is just this anyway. It's just this. So I will now say negative 2t times 4, which I'll get negative 8t. And then open bracket 4 minus t squared, and then close bracket to the power 3. So that's how you differentiate that. Now, in your case, you will not be asked to do all those kind of stuff, but you need those principles for you to answer some questions. For instance, if you are given a question to say, given that y is equal to 4t squared plus t plus 10 represents the displacement of a car moving in a straight line, where t is time in seconds. Calculate the velocity of the car in terms of t, which is the time, acceleration of the car in terms of t, displacement of the car from the origin. Now, what do we do here? First of all, if you are given the displacement of the car, or maybe the displacement function, to get your velocity, you just differentiate that same function. Which function? The displacement function. So whenever you want to find the function of velocity, when you are given the displacement function, differentiate. Similarly, if you want to get the acceleration, differentiate velocity. Then you have your acceleration. I will talk about going backwards when you are given acceleration and then you are asked to find displacement or velocity. That's when now we look at the aspect of integration. So like in this case, they are saying find the velocity of the car in terms of t. You differentiate this, and definitely we are using now the same concept of which when you differentiate that, you will get 8t plus 1 meters per second. To find our acceleration over here, you are going to differentiate velocity. This is what I've already said. At meaning acceleration or acceleration of this car in terms of t will be dv dt. And then when you differentiate 8t, you get 8. To differentiate 1 is a constant number, that's 0. And then you have 8 meters per second squared. To find our displacement, this is the displacement function, but now they are saying now at this point, when this car stopped, find the distance that was covered. So what we are going to do is that, you see, when a car has reached its maximum point, or let me say it has stopped moving, meaning that the velocity, not displacement, velocity function will be equal to 0. So I'm going to get this 8t, which is the velocity function, 8t plus 1, and then I'll equate to 0, so that now I can find what is the value of t. When I get that value of t, then I'll substitute it back into the displacement function. And if you're going to do that, you must be able to get the answer as 9.94 meters as your displacement.